So have you heard about this company DeepSeek?
Yeah, I've seen their name pop up a few times recently, mostly on like those AI forums.
Hmm.
People are buzzing about them.
Yeah, well, they're this Chinese AI company, and the reason everybody's talking about them is that their models are like outperforming some of the big names, like OpenAI, Google, those guys.
Really? Wow. I mean, that's impressive, but those companies have like massive resources. How's a smaller company like DeepSeek even competing with them, let alone beating them?
That's the crazy part. They're doing it with way less powerful hardware and way less power in general. It's like a total David versus Goliath
So
situation.
what's their secret? Are they using some completely different kind of AI or something?
That's what we're going to try to figure out in this deep dive.
Yeah.
We've got research papers, some tech analysis articles, and even those forum discussions you mentioned where people are trying to reverse engineer DeepSeek's
Oh,
methods.
wow. That's cool. Like a little detective work.
Exactly. So our mission is to figure out how they're achieving this crazy efficiency, especially when it comes to GPU usage, and then like what that could mean for the future of AI, what this means for all of us.
Yeah, that makes sense. Like, is this the start of a trend or is DeepSeek just a one-off?
Right. So
Yeah.
where do we even start?
Well, the first thing to understand is that it's not like they found this like one magic trick.
Okay, so it's more complicated than that.
Yeah, DeepSeek's using this really smart combination of design choices in their models,
Hmm.
and then they're layering on these optimization techniques on top of that.
Yeah.
Like they're really squeezing every last bit of performance they can out of their hardware.
Okay, so let's unpack that. What are some of these design
Well,
choices?
the foundation of their approach is something called a mixture of experts system.
MOE, right. I've heard that term thrown around, but to be honest, it always sounded like AI jargon to me.
Yeah, I get that. But it actually makes sense when you think of it like a brain, but with specialized departments.
Specialized departments.
Right.
Okay.
Yeah. So like, let's say the model needs to translate a sentence, right? Instead of activating every single neuron for every possible language task, and MOE system just calls on the specific expert for translation.
So only the neurons that are needed for that specific task are activated.
Exactly. This saves a ton of processing power
Yeah.
because not every part of the model needs to be running all the time.
Oh, okay. So it's like having the right tool for the job, which, I mean, that's intuitive, right?
Right. And the thing that DeepSeek is doing that's even more unique, they figured out how to make this specialization work during the training process itself.
Not just when you're using the already trained model.
Exactly. And that's huge because training these massive AI models is usually the most resource-intensive part, like by far.
Yeah, that makes sense. So they've kind of optimized the learning process itself, not just the final product.
Interesting. Okay, so what else are they doing on the architecture side? I keep seeing multi-head latent attention mentioned too.
Yeah, MLA. That's another key ingredient in their approach. I'm trying to wrap my head around what that even means. Multi-head latent attention.
Okay, think about it like this. Imagine you're trying to understand like a really complex research paper. You might scan it multiple times, right?
Hmm.
Each time you're focusing on a different layer of information. Like maybe the first time you're looking at the argument, then the methodology, then the supporting data.
So you're breaking it down into chunks.
Yeah. And MLA allows the model to do something very similar. It processes information way faster and more accurately by having multiple heads that are each focusing on different aspects of the input at the same time.
So if MOE is about specialization, MLA is about parallel processing, like multitasking, but on a superhuman level.
Exactly. And one of DeepSeek's big innovations with MLA is how they've used it to compress the memory that's needed for those context windows.
Context windows.
Yeah, like how large language models have to basically remember all the previous information. Well, that usually takes a ton of resources, a huge resource hog. But DeepSeek's approach seems to be way more efficient.
Okay, so they've got these really clever architectural tricks, right? But on top of that, there's this whole other layer of optimization techniques they're using during training. It's almost overwhelming how many they've implemented.
It's not just the quantity, it's the way they've combined them. And one area they've really focused on is parallelization, which is basically splitting the workload across multiple GPUs.
Divide and conquer, right? Like break the problem down into smaller pieces.
Yeah. But they do it in like 3 different ways for maximum efficiency. They use pipeline parallelism, where each GPU handles a different stage of the process.
Like an assembly line, right?
Exactly. Then there's expert parallelism, where the workload is distributed among those specialized experts within the model.
Oh, right, those experts we were talking about earlier.
Yep. And then finally, there's data parallelism, where the data itself is split across multiple machines.
So they're optimizing on multiple levels, it sounds like. Like how the work is divided, what each worker is best at, and even how the raw information is fed into the system.
Exactly. And then on top of all of that, they have this really ingenious algorithm called dual pipe.
Dual pipe. Yeah, I think I remember seeing that mentioned somewhere. It has something to do with keeping the GPUs busy, right?
Exactly. Think about those moments on an assembly line where one worker's just waiting for the previous one to finish their task,
Yeah.
you know,
Yeah.
wasted time,
Downtime.
right? They call that pipeline bubbles. And dual pipe helps DeepSeek avoid this
Yeah.
by cleverly overlapping the computation and communication between the GPUs. It's like perfectly choreographed teamwork.
Okay. I'm starting to see how all these pieces fit together, but what about memory usage? Isn't that like a major bottleneck with these huge models?
It definitely can be. And DeepSeek's made some deliberate choices there, too. For example, they specifically avoid a technique called tensor parallelism.
Tensor parallelism.
It's known for using up a ton of memory, like the real memory hog.
So they're consciously choosing methods that are lighter on memory?
Exactly. And this lets them use less powerful and therefore cheaper GPUs, which is another big win for their efficiency.
Okay, that makes sense. Now, there's this one thing that keeps popping up that I have to ask about. It's FP8. It sounds super technical. What is that all about?
Ah, FP8, or 8-bit floating point. This is where things get really interesting. So imagine you're trying to store information, like numbers, right? The usual way AI models do this is with 32 bits per number.
32 bits, okay.
But DeepSeek is using a much smaller container for these numbers, only 8 bits.
So it's like they're writing a book in shorthand to save space.
Yeah, that's a good way to put it. This drastically reduces the amount of memory needed, which is great for efficiency. But the real magic is how they maintain accuracy, even with this shorthand.
Yeah, because you'd think cramming all that information into a smaller space would cause problems.
You'd expect that, right? But they've developed some innovative techniques to counteract that. One is called fine-grained quantization, which basically means they divide the numbers into smaller chunks and adjust each chunk individually.
Okay, so instead of having a ruler with just inch marks, they've got one with millimeters, so they get more precision.
Exactly. More precision, even with smaller numbers. And then they also use something called increased accumulation precision, which is like having a larger scratch pad for their calculations.
Yeah.
This helps to avoid those little errors that can creep in when you're working with small numbers repeatedly.
It sounds like they're walking this tightrope between pushing for maximum efficiency, but also making sure they don't sacrifice accuracy.
Yeah, it's a delicate balance. And DeepSeek seems to have found a way to make it work.
Well, that's impressive. Now, here's where things get even more mysterious.
Oh, lay it on me.
The whole CUDA situation.
CDA, what about it?
Well, it seems like they're using CUDA, which is NVIDIA's platform for GPU programming, right?
Right.
But it also looks like they're bypassing it sometimes.
Interesting. So they're using it, but also not using it.
Yeah, it's weird. It seems like they might be tapping into PTX, which is like a lower level programming language. It basically gives them more control over the GPU.
So if CD is like driving a car, PTX is like getting under the hood and tweaking the engine directly.
Yeah, basically. And this could explain some of those speed gains they're seeing, because they're not just using the standard tools, they're building custom solutions.
So it's like they're hacking the system to get the most out of it. That's pretty impressive. But, I mean, that sounds incredibly complex.
Yeah, it definitely requires a high level of expertise and a certain, like, hacker mindset. They're not afraid to push boundaries.
That's really cool.
And speaking of shaking things up, I was reading that AMD, one of NVIDIA's biggest competitors,
Yeah.
they officially announced that they're supporting DeepSeek's models on their Instinct MI300X GPUs.
Wow. Okay. That's a big deal.
Yeah, I mean, this suggests that DeepSeek isn't limiting themselves to just NVIDIA, the hardware. They're actively looking at alternatives.
Which makes sense if they're all about efficiency. They're not going to limit themselves to just one company's products if there's something better out there.
Right. And then their open source approach. That could really encourage a more diverse market in the AI world.
Oh, yeah. Definitely. More competition is always good. It drives innovation.
Okay. So we've covered the architecture, the training optimization, but they're also thinking about how to make actually using these models just as efficient, right?
Yeah, absolutely. It's not just about training them. It's about how they perform in the real world. And DeepSeek has some really cool tricks up their sleeve for that, too.
Tricks up their sleeve. I like
They're
that.
all about making sure their models are as efficient in practice as they are on paper.
All right. Well, let's dive into that in the next part of our deep dive.
Yeah, I'm really curious to hear more about that. This is already blowing my mind.
This is just the tip of the iceberg. There's so much more to uncover,
Yeah.
and it gets even more interesting, trust me.
I can't wait. So DeepSeek's approach to this whole inference thing, it's all about making sure their models are just as efficient in the real world as they were back when they were training them.
Right, because what's the point of having this super efficient training process if the model gobbles up a ton of resources every time you actually want to use it?
Exactly. And they've got a few tricks up their sleeve for achieving this.
Oh, I love tricks. Spill the beans. What are these tricks?
Well, one technique they use is called test time scaling. It's kind of like imagine a car that can shift gears depending on the terrain.
Okay, I'm picturing it.
So if the model is dealing with a really complex task, it can like ramp up its computational power. But for simpler tasks, it dials things back, to save resources.
So it's dynamically adjusting like its effort level based on what's needed.
Yeah, basically. Pretty clever.
Exactly. Portal.
They also have this concept called inference time computing, which is all about only activating the necessary parts of the model for each query. Like only turning on the lights in the rooms you're actually using.
Okay, yeah. Why waste energy on the parts of the model that aren't relevant to the task at hand?
Exactly. And then they take it even further with this technique called distillation.
Yeah.
Imagine you have a big, complex recipe, yeah,
Okay.
and you want to condense it down to a simpler version that still produces the same, like, delicious dish.
Okay, so you're streamlining it, but
Yeah.
keeping the essence.
Exactly. That's what they're doing with their models, creating these, like, concentrated formulas
Mm-hmm.
that are smaller, faster, but still retain the core knowledge of the original model.
So they're making these like AI Cliff's Note.
Yeah. And this is huge for making AI accessible on less powerful devices like smartphones. You wouldn't want to run a massive AI model on your phone.
Yeah.
It would drain the battery in like 5 minutes.
Yeah. No, that makes sense. So we've covered the architecture, the training optimization, and now the efficient inference. I'm starting to get a picture of how DeepSeek's gotten so successful. But like, zoom out for a sec. What does all this mean for the bigger picture? What are the implications of all this?
I think DeepSeek is sending a really clear message to the whole AI world. Efficiency matters. Their success challenges this assumption that you need mountains of computing power and tons of expensive hardware to achieve, breakthroughs in AI.
It's not just about building bigger and bigger models.
Yeah, it's about being smart, resourceful.
And this could have a ripple effect throughout the whole industry, right? Like
Yeah.
we might start seeing a shift away from this bigger is always better mentality and move towards a focus on optimization, software innovation.
Right. And this could also like level the playing field a bit,
Yeah.
make AI development more accessible to smaller companies, research groups, the ones who can't afford to build those giant server farms.
Right. Yeah, because those costs can be astronomical. It's like an arms race sometimes. Okay, but let's get back to some of the specific techniques they're using for a moment. I'm still a little fuzzy on some of the details. Could we break down a few more of those optimization strategies?
Sure. Let's take data parallelism, for instance.
Data parallelism. Okay, remind me what that is again.
It's a pretty simple concept. Imagine you have a huge data set,
Right.
right? And you need to train your model on it. Instead of processing it all on one GPU, you split it up
Okay, split it up.
and distribute it across multiple GPUs. So they're all working on their assigned chunks simultaneously.
So it's like having a team of workers tackling different parts of a big project instead of one person trying to do it all alone.
Yes. Great analogy. And all this parallel processing really speeds up the training. Then there's pipeline parallelism, which is a bit more like an assembly line. Each GPU handles a specific stage of the process, and the data flows from one GPU to the next.
So like one GPU might be pre-processing the data, another one's running the calculations, and then a third one is handling the output, each one specializing in its task.
Exactly. This division of labor makes sure that each GPU is working at its full capacity, and it avoids any bottlenecks in the process. And then we have expert parallelism, which, as we said before, is all about distributing the workload among those specialized experts within the model itself.
So going back to our assembly line, it's like having different stations for assembling different components of the final product.
Right. It's all about maximizing efficiency by using the right resources for the right job at the right time. Now, What about those low precision floating point numbers we talked about, the FP8?
Yeah, that one really stood out to me. It seems almost counterintuitive to use like less precise numbers when you're dealing with something as complex as AI.
It does, doesn't it? But DeepSeek's made it work. Remember, FP8 means they're using smaller containers for the numbers, which reduces memory usage and speeds up calculations.
But how do they deal with the potential loss of accuracy?
They've got some clever techniques to mitigate that. One is called fine-grained quantization, which basically means they divide the numbers into smaller blocks and adjust each block individually. It's like having a more precise measuring tool.
So they're not just rounding off the numbers, they're being very deliberate about how they handle that reduced precision.
Precisely. And then they use something called increased accumulation precision, which is like having a larger temporary storage space for calculations to avoid like errors piling up.
So they're being extra careful about how they handle those smaller numbers to make sure they don't end up sacrificing accuracy. It's amazing how much thought they've put into all of this.
It's really remarkable. Now, we were discussing their use of the PTX programming earlier. Remember, that lets them kind of go beyond CUDA and really tinker with the GPU.
Yeah, getting under the hood, right?
Yeah. You mentioned it gives them finer control over the GPU's hardware. Do you have any like specific questions about how they might be using that control to get better efficiency?
Yeah. Can you give an example of what they might be doing? Like what kind of fine-tuning are we talking about?
Sure. One possibility is they're using PTX to optimize memory access patterns. Accessing memory is one of the slowest operations in computing. So if they can carefully structure how the data is stored and retrieved, they can really speed up their calculations.
So it's like organizing your tools in a workshop so you can quickly grab what you need without wasting time searching around.
Exactly. Or they might be using PTX to exploit certain hardware features of the specific GPUs they're using, something that might not be possible with the more general-purpose CUDA framework.
It's like they're speaking the GPU's native language almost to get the most out of it. But, let's step back for a second. Think big picture again. We've touched on how DeepSeek's approach could impact the AI industry as a whole and even democratize AI development. But I'm curious, how do you see this playing out long term?
That's a great question. It's hard to say for sure, but if DeepSeek's approach does catch on, I think we could see a dramatic shift in how AI is developed and deployed, like really dramatic.
Okay, I'm intrigued. So where do we go from here?
Well, why don't we explore some of those potential scenarios in the final part of our deep dive?
So we've spent this deep dive uncovering how DeepSeek's doing it, how they're achieving this crazy efficiency, right? Through their model design, all their training techniques, even how they're using the hardware.
It's really pushing the limits.
Yeah.
Like what's possible with AI right now?
Right. So now the big question, what does this all mean for the future, right?
Right.
What happens if this approach, DeepSeek's approach, becomes the standard? How does that change how all of us, how we interact with AI?
It's kind of hard to wrap your head around. It's exciting, though, if this whole focus on efficiency really takes hold.
Yeah.
I can see a future where AI isn't just limited to, those massive data centers,
Yeah.
and expensive supercomputers.
So instead of it being this mysterious force that's locked away in server farms, it becomes more, I guess, a bigger part of everyday life for all of us.
Exactly. Imagine a world where your smartphone, heck, even smaller devices, they can run these sophisticated AI models without, destroying your battery life immediately.
Oh, right. That's a good point. Yeah, if they figure that out.
And that could open up a whole wave of, personalized applications.
Like what? Give me an example.
Okay. Imagine AI assistants that actually get what you need.
Yeah.
And educational tools that adapt to how each student learns best.
Right.
Or medical diagnoses that are, more accurate, more accessible to everyone.
Okay, yeah, I see what you mean. Yeah, that could be huge.
Yeah, and it goes beyond just personal devices. Think bigger. Whole industries could transform, like manufacturing, AI could make those factory robots a lot more adaptable, leading to, faster production, lower costs, maybe even bringing some manufacturing back to the U.S. Who knows?
Yeah, interesting.
Healthcare, too. AI could help doctors with diagnoses, personalizing treatment plans, maybe even speeding up drug discovery.
Wow. Okay, so DeepSeek's approach, it's not just about making things cheaper or faster, right? It's about making entirely new things possible, changing what we even think is possible. It's almost like a paradigm shift in how we think about AI.
Yeah, I think that's a good way to put it. It's moving away from just trying to build bigger models towards, making AI more practical,
Mm.
applicable, beneficial for a lot more people.
Right. But with any powerful technology, though, I mean, we got to consider the potential downsides too, right? Like as AI gets more and more integrated into our lives, what are the things we need to be ready for?
Well, one concern is the potential for misuse, obviously.
Mm-hmm.
As these models get more accessible, it's really important to have, some safeguards
Sleepwalker.
to prevent them from being used for, bad stuff, like creating deepfakes, spreading
Yeah, all
misinformation.
right, that makes sense.
The ethical considerations become even more important as AI gets, more powerful and more widespread.
Absolutely. And we also have to think about jobs, right? Potential job displacement.
Oh, right. Yeah, of course.
Yeah.
As AI gets more capable, some tasks that humans do now, they might be automated, which is, it's scary for a lot of people.
It is. It really highlights how we need like better education and retraining programs to help people adapt to all these changes.
Sure.
We need to make sure the benefits of AI are shared by everyone, and that it doesn't make existing inequalities even worse.
100%.
Yeah.
We need to be talking about this,
Yeah.
like having these open conversations about how AI is going to affect society and
Certainly.
working together to create a future where this technology really does benefit everybody.
Right, right. Because technological advancement, it's not always a straight line to progress. We know that. There are going to be bumps along the way. And it's our responsibility, all of us, to deal with those challenges thoughtfully,
I think so,
ethically.
yeah.
Okay. So we've talked about the risks, but I want to go back to one of the most exciting parts of this whole DeepSeek thing, their commitment to open source. Do you
Mhm.
think that could be the key to like unlocking AI's true potential?
I think it could be. Open sourcing their models is a big move,
Hmm.
really bold,
Mm.
and it has the potential to change everything. Well, by sharing their knowledge and technology, DeepSeek's encouraging collaboration,
Right,
transparency,
right.
and that could lead to a much faster pace of innovation. Because they're not hoarding all their secrets; they're inviting the whole world to come along for the ride, basically.
It's like a global brainstorming session,
Yeah,
but with AI.
yeah. And think about all the different perspectives, all the expertise that people from all over the world could bring to this, building on DeepSeek's work.
Yeah. That's a really powerful idea. So DeepSeek, I mean, it's more than just a company, right? It's like a symbol of this shift in how we're thinking about AI,
Hmm.
moving towards collaboration,
Mhm.
accessibility, and a focus on solving, real problems that people face.
That's a great way to sum it up.
Well, this has been an incredible deep dive. We've explored DeepSeek's, their techniques, the impact they could have on all these different industries, and even the ethical questions that we need to be thinking about. They're definitely a company to watch.
Yeah, this is only the beginning for them.
It's an exciting time to be following AI. It's changing so fast. Who knows what amazing innovations are just around the corner?
I can't wait to find out.
Me too. But for now, that's it for our deep dive on DeepSeek. Thanks for joining us, everybody. And until next time, keep exploring, keep learning, and stay curious about the world of AI.